In this video, I will show you an easy proof of Menelaus' theorem. Menelaus' theorem states that if we have a triangle ABC with a line intersecting AB at M, AC at N, and BC at P, then we have this equality: AM over MB times BP over PC times CN over NE is equal to 1. And to start our proof, we need to draw a line passing through C and parallel to MN. So our parallel line intersects EB at S, and we will use the intercept theorem in the triangle BPM. So in the triangle BPM, we have in this triangle BPM, we have SC is parallel to MP. SC is parallel to MP. So we have BP over BC, applying the intercept theorem. BP over PC is equal to, here BP over PC is equal to BM over BP over PC is equal to BM over MS. And the second triangle that we will use is the triangle ESC. The triangle ESC. In this triangle, the triangle ESC, we have MN is parallel to SC. So applying the intercept theorem, we have Cn over Ne, Cn over Ne is equal to Cn over Ne is equal to Sm over Me over Me. Now multiplying the two equalities term to term, this term times this term is equal to this term times this term. So BP over PC times Cn over Ne, Cn over Ne is equal to Bm over Ms, Bm over Ms times Sm over Me, Sm over Me. And here you see this term will just cancel. It's the same number. So we'll have BP over PC times Cn over Ne, Cn over Ne is equal to, and here we will have just Bm over Me. This term just cancels. And from here, taking Bm over Me to this side, to the left side, we will have BP over PC times Cn over Ne. Here, if this term goes to the other side, it becomes the reciprocal. It becomes Me over Bm, of course, is equal to 1. And now the final step is just to rearrange our equality. So here, starting with this term, we have Me is Am over Bm or Mb, Em over Mb times Bp over PC, BP over BC times Cn over Ne. Cn over Ne is of course equal to 1. And this of course concludes our problem.